So now we're going to see direction-based method to solve this question. Okay, so you can see first thing first that there are two arrays which are of size 4 named TR and DC. Okay, they have fixed values 0, 1, 0, -1 and 1, 0, -1, 0. Okay, so we are going to use them combined. So 0, 1, 1, 0, 0, -1, -1, 0. These four depict four directions that we can travel. First one being right, next being down, third being left, and fourth being up. Hence, they are designed in the same pattern as we have to move in spiral direction. Okay, first we have to move right, then we have to move down, then we are going to move left, and then we are going to move up. So this is like it's by design that we have used this pattern. Okay, and if you wonder how we can move left, right using this, okay, let me give you an example. You can see here. First, if our initial coordinates are 0, 0, okay, and if we pick the first elements from TR and DC and we add them to these coordinates, we got 0, 1. Okay, so basically, if the initial coordinates were 0, 0 as seen in matrix, now the coordinates should be 0, 1. So 0, 1 being here. So we have moved right basically. Okay, we have reached the next element in the right direction. Okay, same way, if we add again 0, 1 to this 0, 1, we'll receive a 0, 2, which are the coordinates of this three. Okay, so now the thing being how we can detect if we have already traversed to that element. So for that problem, we are going to use this visited matrix. Okay, so it's a pretty tough looking data structure, but it's very simple. It's also a matrix which is going to store Boolean values. Okay, it's going to store Boolean values and it's going to be of size m, and inside this vector we have another vector of size n which is filled with false. Okay, which is initially filled with false. Okay, so in this method, what we have to do is we are going to traverse the whole of this matrix using one single for loop. Okay, there are not going to be four for loops. We are using one single for loop for all the variables. Okay, and we are going to start from row 0 and call 0. Okay, and we are slowly going to move from to call 1, from 0 to call 1 to call 2. Okay, this is going to be a direction to move. So for that we are going to use right. Okay, and so you can see uh, after reaching to each element, first step is going to be push and mark, second step is going to be update for the next element. For that we are going to use new row and new column, which is going to be row and column plus dr of dir and dr of direction. So direction is going to control in which direction we are going to travel. Okay, and these are just the coordinates for the next element. Okay, and then in the end you are going to update row and column. Okay, and will in this same fashion we are going to move in the right direction till possible. Okay, after we have reached all the elements in the right direction, we have reached 3. There's a bottleneck being now mm, now the column is going to be 3 because initially we were at number of column at 2. Now after we did for after this, so if we again add a 0 comma 1, it's going to be 0 comma 3. Okay, it's going to be 0 comma 3. So new column is going to be 3 and new row is going to be 0. This is going to break because there's no element here. Okay, so we have to break at this point, and after breaking the this a special condition I've written here is a if condition. Okay, this if condition is going to work for each and every value that we are going to push, but it takes 5 checks to pass. Okay, any of the 5 checks, if it passes, or are all are based on or not and. Okay, so you can see if number of column, if new column, okay, sorry, if new column is less than 0, that cannot happen. If new column is greater than n, that also cannot happen. If new row is less than 0, again, if new column is less than, if greater than equal to m, okay, and if the element is already visited, okay. These are the 5 checks that you have to do every time. And after doing these 5 checks, as you can see, we have hit one of the case, the second one, we have hit one of the second case. In that time, we are going to do these 3 steps, okay. First, we are going to do a direction change. So first we were in the right direction. Next, we have to move down. So to move down, we just have to add 1 in the direction. And since dir is controlling the directions, we just have to update dir. So to update dir, we are going to use dir is equal to dir plus 1% 4. Okay. So percent 4 for a special reason. I'll discuss it later. And next, we'll have we have to update new row and new column, and then in the end we are going to update row and column. Okay, these are our main controllers for the next element that we're going to push. Okay, so earlier we have moved, our movement was right direction. Now we can move into down. We are going to move in the down direction. Okay, and you can see all the other slides are pretty much the same, in which now we are going to move in the in the downward direction. Same thing, push and mark, update for next element, update rows and column. We are going to move bottom till possible. Now after reaching 9, you have seen the bottleneck, where now the new row is going to be 3, which is not possible. New column remains 2. This is going to break as nr is greater than equal to m. So we are going to update this on the basis of these 5 conditions. Again, we are going to update dir, then we are going to update these, then we are going to update these, and in the end, we are going to change our movement from down to left. Okay, so down to left. Okay, same. And you can see also this part where we are slowly getting all these values as true. Okay, same, we are moving from, now this time we are moving from right to left. Okay, so basically DC, DR and DC are controlling the direction in which we are accessing the matrix element. Okay, after reaching 7, the NC is going to be number of the new column is going to be -1, which is obviously not possible, and number of row remains 2. This is going to break as NC is less than 0. So I have picked this 5 conditions based on these 5 breaking rules. Okay, and again we are going to check same way. Now till now we have moved left direction. Now we are going to move up. Okay, so now we are going to move up. We only have one possible value. We're going to push and mark. We're going to update. We're going to update the row and column. Okay. In the end, we have this filled to. Next, after reaching 4, NR is 0, NC remains 0. So this, it's not illegal. It's not illegal that new row is 0 and new column is 0. It means we are pointing for 1. But it breaks since it's already visited. We have marked it as true and we are visiting again. So among these 5 checks, this one breaks again. Okay. So this time we have dir is equal to dir plus 1% 4. Dir was already 3. Okay, dir was already 3 plus 1% 4. So dir is going to be 0. Hence we have this percent 4. So earlier the movement was up. Now we need to move right direction. Okay, all thanks to that percentage that we reached in the bucket, because of which we can reach to the beginning direction of right again. Okay, so that's it. Okay, that's the reason we have percentage 4, so that you can see after the traversal from 1 2 3 4 we can again start from here. Okay, and that's pretty much it for this part. And after that we are going to fill 5, and our breaking condition is not something like top is less than equal to bottom or left is less than equal to right. Rather, it's because we have completed our final loop. Okay, it's not because it's filled already or something like that. No, it's simply because we have traversed all the elements inside this matrix. Hence, we are out of this loop. Okay, so let's solve. Let's code this one. First thing first, we'll need a dr and tc. Okay, so dr4, and I'm going to mention it using int is equal to. So we'll need 0, comma 1, comma 0, comma minus 1, and int dc of 4 is equal to 1, comma 0, comma minus 1, comma 0. Okay. Next, we'll need a direction int. Okay, so int row is equal to 0, int column is equal to 0, int direction is equal to 0. These two are going to control which element we are accessing, and die is going to control in which direction we are going to move for the next element. Okay. Sorry. So now we'll have int I equals 0, I less than m star n. Okay. As I promised, we are going to use only one loop, I plus plus. Now we are going to first thing first, we are going to push and mark. Okay. And oh, sorry, we also have to make a special vector which is going to store if the element has been already visited or not. So vector bool is going to name. I'm going to name is at visited or visited, and it's going to store size m and the bool n comma false. Okay, so you can see I've created a vector which stores vector inside it, and I've named it as visited of size m. Okay, number of rows, and it contains this another vector which is storing number of columns as n and all the values inside as false. Okay. So next thing we'll need, we first have to push. Okay, so first we have to push and mark. So vector int. Okay, sorry, we need answer dot push back matrix of row comma column. Okay, next we'll need a visited. We have to mark visited row column is equal to true. Okay, simple. So next we have to calculate uh, new row and new column. So new row is going to be row plus dr of direction. Same way, int new column is going to be row, oh sorry, column plus dc of direction. Okay, and you can see dc of 0. Okay, so dc of 0 is going to be 1, and dr of 0 is going to be 0. So these values are going to be 0 comma 1 for the first iteration. Okay, for the first iteration when everything is 0 0. Okay. Next I'm going to write the 5 test cases. Okay, 5 check cases. So if nc is less than 0, or nc is greater than equal to n, or okay, let me just check once. Nc is greater than equal to n, and maybe I can pick them up from here. Yeah. Okay, so these are the 5 conditions on which I'm going to check and update my direction. So my new direction is going to be direction plus 1% 4. Okay, This is going to shift my direction. And after shifting direction, remember to update new row and new column. Okay. New row is going to be row plus dr of direction, and new column is going to be column plus dr of, okay, sorry, dc of that. Okay, so this is everything regarding a direction change. And in the end, regardless of direction change, you have to update the rows and columns. So row is going to be new row, column is going to be new column. Simple. So we have, so you can see, first thing first, push and mark, update for next element, update rows and columns. Okay, so this is update row and column. Yeah, so let's run this. Okay, I've named it as visited. Yeah, so we have completed this. Let's submit this. So you can see we have solved this question using direction based approach. Okay, so that's it. Thank you.